Hello everyone, welcome to the 1.4 notes. Thank you for doing these and doing your homework. These notes shouldn't take very long, so we're just going to go ahead and get right into them. What we're trying to do today with these notes and what we'll do in class on Monday is write algebraic expressions for verbal expressions. So we're basically taking algebra, we're taking words, and we want to translate it to algebra/math. I know that this is sometimes something that we really hate, but it's really important to help us solve problems. And so to do this, we're first going to talk about some vocabulary words that you need to be able to do this. So first, we're going to talk about what does the word variable mean. So maybe you can kind of guess what you think it means, but I'm going to tell you what I want you to put in these words. It is a letter that represents an unspecified number or value. So for example, a lot of times we use X. Say we don't know how much we need of something. We would use X to represent that unknown thing. So a variable is a letter. You could also have a symbol, but for the most part, it's a letter that represents an unspecified number or value. A term is a number. Could be a number, a variable. I'll give you some examples. Or a product or a quotient of numbers or variables. So for example, if you're looking at this algebraic expression right here, 3c is considered a term and 2 is considered a term. So basically is anything that is like separated from addition or subtraction. Those are what terms are. And that's just like to help us communicate, like, oh, the term 3c, oh, the term 2. Next, we have a constant, and that is a term that does not contain a variable. So for example, in this algebraic expression that I just showed you, 2 is a constant because there is no letter or symbol with 2. 3c is not a constant. That's a variable term. Like terms is something that we're not really going to do on these notes, but we're going to talk about in class on Monday, and it's terms whose variables and exponents are the same. Also, because this is a video, if I'm moving too fast for you, you're welcome to pause at any moment. So like terms are terms whose variables and exponents are the same. So for example, if you had like 2x plus 3x, those are like terms because they have the same variable and they have the same exponent. 2x plus 2x, if you were ever asked to combine it, all you do is you add 2 and 3 and you get 5x. An example of non-like terms would be like 2 plus 3y. You can't combine those at all because they're not like terms. Or for example, 2x plus 2x squared. Notice that the exponents, so this one, it doesn't have an exponent. Technically, it does have an exponent of 1 though. But these don't have the same exponent, so they're not like terms. But if they are like, you can combine them. And finally, a coefficient is a number that multiplies a variable. AKA, like this is kind of how it's easy to recognize it. It's in front of or it's attached to the variable. So again, if we go back to 3c, 3 is its coefficient. It's connected by multiplication. We don't normally put a multiplication sign there, but that would be considered its coefficient. So those are what some of these terms algebraically mean. Now, in a second, we're going to write some verbal expressions, but it is really helpful sometimes to have like common phrases that we know that indicate to us, oh, when I write this expression, I should use addition or I should use multiplication. So here are some popular phrases that you hear that would indicate that you should use a certain operation. So for addition, popular phrases are more than, sum, plus, increased by, or added to. These aren't going to be all of the verbal phrases that could indicate addition, but these are some of the popular ones. Subtraction, you would have less than, subtracted from. Like, that's pretty easy. Obviously, you need subtraction. Difference, so what's like the difference of these two numbers? Decreased by, minus. When we get to real world problems, sometimes they won't be this easy and you're going to have to think a little harder, but hopefully we'll have some reps in that will help us get that far. Multiplication, there's a little less for multiplication and division, but product of multiplied by times, and then division, quotient of divided by. So those are some phrases. If you need more time, just pause and write those in. But I'm going to move on. So this says write an algebraic expression. So an expression, just so you know, the difference between an expression and an equation is we don't need an equal sign. So we're just doing expressions right now. We don't necessarily need an equal sign. So example 1 says write an algebraic expression for each verbal expression. So this first one says 2 times the quantity y plus 11. So I'm going to go ahead and highlight some things for myself. First, we have some numbers. So I'm going to highlight those in one color. And then I'm basically just going to highlight everything. Then I'm going to underline like the verbal phrases that seem important to me. So times seems important to me. And then plus seems important to me. And then we also have this phrase quantity too, which is interesting. So we're going to go ahead and do that. So we're going to do 2 times something. So 2 times, because times is a form of multiplication, and it says the quantity y plus 11. And so what the quantity indicates when it says it like the quantity like that, what it wants you to use is it wants you to use parentheses. So the quantity of y plus is obviously a plus sign and then 11. And so that's what your answer should be right there. So if you ever hear the phrase quantity, know that you should be using parentheses around whatever it says it wants the quantity of. Here's our next one. N cubed increased by 5. So I have like 2 things that we're working with. I have an n and I have a 5, and then increased by, that indicates to me that I should use addition, but cubed, that wasn't in any of our popular verbal phrases. But cubed just means an exponent of 3. So that just means an exponent of 3. So I'm just going to go left to right. So if I do n cubed, that means I would do n cubed. And if I want to increase that by 5, I would just do plus 5, and that's our answer. Okay, one more like this, and then we're going to start working with some like word problems, which that gets so much harder, but it's really not bad. You just have to get used to thinking that way. This time I'm going to highlight like my numbers and my variables. So 18, 3, and D, those are like the things that I'm going to do stuff to. And then we have increased and we have product. So we're going to do 18. And it seems like we're going to increase that. So increase means plus. And then the product of 3 and D means multiplication. So that means I'm going to do 3 times D. And you can write it like that, or you can write it like this, because technically you can just put a variable and a number right by each other because it's just the coefficient. So either of those are sufficient answers. So if you need any help with that, just let me know in class, but that is good practice. Now we're going to write algebraic expressions for situations. So these are all real world, and I want to give you kind of some of my tips and tricks for this. So it says Donald has P peppermints. Greta has 4 fewer peppermints than Donald. Choose the expression that shows how many peppermints Greta has. So I got these off of IXL, so we're not going to choose it. We're going to write the expression, and I'll edit these notes. So these will only show up on my side. Whoopsies, sorry. Okay, so I'm going to go through this A problem, and I'm going to highlight first, like, what are some of, like, I'm going to highlight the numbers and variables first. So we're calling peppermints P, and then we have this 4 number, which says fewer. If I'm going to write an expression, to indicate how many peppermints Greta has. So my final answer is going to tell me how many peppermints Greta has. And another phrase that sticks out to me, because it is one of those like popular verbal phrases, is fewer. So that indicates to me that somewhere I'm going to have to use subtraction. So P represents Donald, and Greta has less peppermints than Donald. She has 4 less than Donald. So if he has P peppermints and she has 4 less, like for example, if he had 6, then she would have 2. And the way that I figured out that is I just did 6 minus 4. So all I have to do here is do P minus 4. And that is our answer right here. So sometimes, like, if I really can't think of the algebraic expression, I like to think about, like, okay, well, what if Donald had this many peppermints? Like, how would I go about figuring that out without using algebra? And that helps me a lot of time put the algebra together. Okay, 3 more problems. Ashley has 6 bananas to bake loaves of banana bread. Each loaf used B bananas. Write the expression that shows how many loaves Ashley baked. Okay. So she has 6 bananas. So I'm going to highlight that. And then it says each loaf that she created used B bananas. And my end goal is to figure out how many loaves she baked all together. So there's nothing really like verbal in here, so I'm like, oh, what am I supposed to do first? So sometimes if I can't figure out what I need to do, let's just like make up a number of bananas, right? So let's say that let's just say that like each loaf needed 2 bananas, right? So if I made 2 loaves of bananas, I would have 4 bananas. And if I made 3 loaves, sorry, not bananas, if I made 2 loaves of banana bread, I would need 4 bananas, right? And if I made 3 loaves, I would need 6 bananas. So basically what I'm doing is I'm multiplying the amount of bananas by the amount of loaves. Well, we know that she has, if we think about that in reverse, we know that she has 6 bananas, and we don't know how many loaves she has. But basically, if I did 6 divided by the amount of bananas, that's how many loaves I could create. So say B was each loaf needed 1 banana, then I could make 6 loaves. But if it needed 2, I could only make 3, etc. So that's just kind of like how I think about it to picture it, but the answer right here is 6 divided by B. 2 more. We have Garrett, and he bought 4 pounds of red apples and G pounds of green apples, right? The expression that shows how many pounds he bought in all. So at the end of the day, we want to figure out his total. So we're going to work with 4, and we're going to work with G, the pounds. How many he bought in all means I need a total of something, and so total normally indicates to me addition. So if I say he bought 3 pounds of of green apples, I would do 4 plus 3, and I would get 7, and that would tell me his total. So basically, to find his total, I'm just going to do the 4 pounds of bananas we know he has. Sorry, I keep saying bananas. I'm so sorry. The 4 pounds of red apples we know he has, and then we don't know how many pounds of green apples, but we have a variable to represent that. So that would be our answer. So our answer would be 4 plus G. Last one is Ling went to Krispy Kreme to buy donuts. Each box of donuts has 12 donuts. Write an expression to represent how many donuts Ling bought if he bought D boxes of donuts. So he's going to the store. He keeps buying boxes of donuts, and they have 12. So, for example, if he bought 2 boxes of donuts, he'd have 24. I know that because I just did 2 times 12. And if he bought 3 boxes, he bought 36. I did 12 times 3. So if you notice, I'm just doing multiplication there. I'm multiplying the amount of donuts in a box by the amount of donuts. And that would tell me my total amount of donuts I had altogether. So that would be your answer. So you can either write 12 times D or 12D. And that's all of our notes. We'll keep practicing. Feel free, if there's something that doesn't make sense, just send me an email and I'll get on that. Thank you.